Hi, Tony back with you again. I'm in my workshop this morning and I'm surrounded by, as you can see, loads of Sigenergy equipment all over the place here. Now, this particular bundle is going off for a job. It's earmarked for about 7 to 10 days time, ready to go in. But unfortunately, I've received a letter from the SEAI saying that this, or parts of this, are unsafe in their opinion. They have safety concerns. Now, these are kind of strong words. They're not saying the inverter is unsafe or the batteries, but this gateway here, they're saying does not conform to current standards in Ireland and therefore cannot be installed. So the only thing I can find that's unsafe about this equipment is lifting those batteries on your own, the 8 kilowatt ones. Very heavy, definitely a 2-man lift. So let's see what we can do about conforming to these new rules. Okay, so this is our Sigenergy gateway all unpacked, and we'll have a quick look at this. Now it's high quality, all metal with rubber seals. I wouldn't put it in the rain though. If you look over here, this is the most important part here. This says grid, and your grid comes in. That's from your DNO supply. In our case, it's ESP network supply, phase neutral. There's your grid. Smart pull is so you can just connect a backup generator. We're not going to go near that today. And inverter 1 is where we're going to be putting our Sigenergy inverter. That's that one over on the ground there, 5 key VA inverter. We're going to be putting that direct into phase neutral there. The other two, inverter 2 and inverter 3, we're not using on this job. They'll stay off. And then backup. Now this is probably the most important one. Backup means, of course, you've got your SPD and you must have that switched on. But backup means that's your link over to your distribution board, your fuse board, in layman's terms. And over here I just set up a blank empty fuse board here, so that backup would come over here into your double port isolator, and then you'd have your SPD and all your RCBOs going off to all of your RCD protected circuits throughout. That's where that goes to. But for us to understand this issue that we have with Safe Electric at the moment, is we have to look at earthing arrangements. Now we have TT and IT earthing arrangements where this actual panel is designed to meet those as well, because they don't just sell this equipment in Ireland, they sell it all over the world. So we'll come on to that in a minute. We don't use that. We are using TNCS here as a matter of course. So you basically have your power supply coming in from the street, you have your 3 phases, or just 1 phase in this case, single phase box, and your neutral and earth are linked together right where the DNO meter is, the ESP electricity meter. They're linked together there, and this does a great job for fast disconnection times of your MCBs and your over current protection. It does a great job of that. Now, to understand this a bit more, we have to go back to the regs, and this is the IS 10101, and here under generators it says, we read this, the short circuit power supply of the standalone generator set shall be such that the overcurrent protective device or residual current device are able to disconnect the circuit in accordance with, and that will be requirements of 411.4, which is just going to be like our graph there, our table, sorry, and it's just going to give us our disconnection times in resistance in ohms. And basically we're using RCBO type B. We're looking at something like, say, if it's just sockets 2.3, we're just going to go with that for now. So we come over here to back to the gateway, and this is some of the issues that we've been having, that's people are just not connecting these up correctly. So we know we've got our DNO supply there, our phase and neutral there, and our earth is going to be on this earth bar here. Ignore that right in above. This is our earth bar. So that's our earth coming in, and the next one there is probably going to be our earth going out on this backup supply. And then there might be an electrode as well going in there, and there is a link obviously as well to the SPD. So these are all quite simple things. But if we look at this terminal here, this is our ground terminal, and this is our earth neutral link. It's very important. We have to link this across. It automatically, on the event of a power failure, automatically links the neutral of the inverter across to the earth here. And we cannot put our electrode straight in there because we're not using a TT or an IT system. we have to do this instead. You can see here, I crimped a lug on here and made a fly lead, and I basically just popped that into place there, tightened down the screw, and now this combines, giving us back a TN system again. So next time the power is off and the inverter is on and we do our earth fault loop impedance test, we will get a nice value. We won't get, if we just had an electrode in there or nothing in there, we would only get like 80 ohms, 100 ohms, maybe even 200 ohms, whatever the gas and water are given. You know, it's not right, it's not connected correctly. But as soon as we pop that one back in there again, we're going to be right back down to our 0.7 ohms or 1.1 ohms or whatever was perfectly acceptable and within that table's parameters. Okay, for issue 2, we're back to the regs book, and as you can see there, this is IS 10101 or 10101, however you want to say it, and it's got this new stripe on there, which means it's the latest edition. And we're going to have a quick look at this regulation here, and you'll find this on 712.537.4.1. This is leading to our second large problem with these gateways. Emergency isolation. Basically, this states that you have to have a single point of isolation for every installation. So basically, if the fire brigade come into the property because you've left an electric blanket on, you've gone to work or something like that and it's smouldering away, they want to be able to hit one switch and know where it is. And that's why we have stickers, labels on the outside meter, on the fuse board, everywhere saying where that single point of isolation is, and we have to comply. So if we just quickly read this: in order to provide emergency isolation of the circuits from the PV array into the building, the following requirements shall be met. And we come down here and we provide an isolation of circuits from the solar PV module into the building, whether this circuit is AC or DC. And that's where we're getting called out because we already have the DC covered. I'll jump up into the attic and I'll show you how we cover the DC. Right, we call this a shunt, or some people call it a fireman's switch. Some people call it rapid DC disconnection. Call it what you like, but we're up in the attic now, and you can see 10 panels of PV go off onto that roof, and 10 panels go off onto that roof, and they both come into here and here, this side of the fireman's switch or shunt. Now when this shunt is powered up, it activates the other side of the shunt, which is our DC that goes down to the inverter. And you can see here, this will only put our DC through when we have power in this box here, AC out supply in this box here. So our DC is active at the moment, and this is our rapid disconnection. So basically this AC supply, I will show you downstairs. This is not our Sigenergy system. This is a bit of a demo system that I wanted to show you just as an example. From the distribution board over here, we come down to our AC isolator going into our generator, which is our inverter there, and the DC strings, the other side of those two shunts are here. Quite simple. Now this shouldn't actually have a switch on it, it should just be a fused spur, but it's basically an MYMJ going up this separate trunk in the AC side into the distribution board, and it's fused at 3 amps, and it's powering constantly our fireman switch or shunt, which is up in the attic, off the bus of the distribution board there. Very important. So when that bus is live, it's on a RCB B6 actually. When that's live, our DC is active. So if I was to throw the main switch onto this, our DC would automatically disconnect, and if I was to switch it back up again, it would automatically reconnect. All those words are in the regs there. Back to the gateway then. So that's our DC taken care of. I showed you what happens up on the roof with the DC rapid disconnection. And now for our AC, because we haven't satisfied the AC that was on the rules there, and we haven't satisfied the single point of disconnection. So for our AC, there's 2 ways to do this, quite simple. I'm just going to show you a relay, a contactor. Okay, this is a Hager, this is a 25 amp. I wouldn't use this one, I'd use the double mod. This is only a single mod, but it is double pole 25 amp, which is exactly what our inverter is going to be. And we could put this in here. I'm not sure if it would invalidate the warranty. we could put it in a box enclosure like this one here outside, or we could actually just put it right next to that big yellow isolator that was doing the PV in the utility room that I just showed you. So we could just put an MC B6 and the contactor in one of these boxes right next to there. Now the whole point of this being that this cannot be fed permanently when the power goes out, because we won't have a single point of isolation. So we quite simply feed this contactor. We have an A1 at the top, not quite in focus, and an A2 at the bottom. And just to show you, the A2 is just going to go to the neutral bar. This is the same feed that feeds our rapid disconnection for the attic, our fireman switch or shunt. And the phase is just going to go up to, it's a bit messy there, but it's just going to go up to the same MCB to B6 that's feeding that as well. So this is going to be active when the bus of the consumer unit distribution board is live. And we quite simply bring our inverter feed, instead of going straight into there with our inverter feed, we go through this first and then over into there. That's number one. That will disconnect everything. Smart port will go, everything will go, because this is already disconnected. You basically are disconnecting, you're doing 3 jobs in one with the distribution board main switch, which is going to be over the double pole that I mentioned there. I did also say that you need stickers, and these are the stickers. We basically put these on everything, and it tells you where, tells the fire brigade exactly where to disconnect, and everything is labeled neatly. Now there's another way to do this as well. This is your kind of 230 volt method of doing it, but there is actually a low voltage method of doing it, because you might want to put the relay somewhere else, like up where the other fireman switch is, or somewhere closer to the panels. And this is the other method of doing it. So basically you see we have volt-free contacts here in the gateway itself, and I'm looking there at terminals 5 and terminal 6. So it's DI1 or D11, looks like DI1, and ground. Those 2 terminals there, simply they're connected to the 2 terminals at the bottom of this other relay that I'm showing you as a demonstration, and I've just put a loop in the top there. So those 2 there are basically permanently contacted together when A1 and A2 is powered up off the bus again. So this takes a little bit more setup, but it's a nice way of doing it. So with this, we have to refer to the app, and the installer has to do the work here. So we come over to the app here, we open up the app, and we go into installation and settings and tools. I can send this over to you. Anyone needs this PDF, it's very easy to follow. Basically it's telling us terminal 5, and here the ground is 10, or ours was 6. Never mind, it's giving us the full instructions of what to do. And on the app, in the installation tools, we basically simply set up this DI, we switch that on, and we change our grid settings to the inverter will only ever be powered up if those 2, D5 and D6, are shorted together. It's quite simple. People often use this type of system as well to disconnect in a fire situation where their fire alarm panel also keeps alive the signal for the inverter. So it's really easy to do, really simple, and in about a week to 10 days time, when I install this equipment, I'll show you all of these things working.